Okay, so yesterday we looked at monic factorizations, and halfway through I was reminded that you've actually done monic factorizations in regular maths. And I know that you've done non-monic factorizations as well, but I want to show you a particular method. So that's the goal for this lesson, is to demonstrate the method and get you to practice the method using the puzzle sheet. And I'm going to try my best to try and prove to you that the method's actually pretty good, works pretty well. Because I know there are going to be some doubters here. The same doubters that prefer to go to Strawn just to get to Launceston. Can I just say, because I've said this a few times now, Strawn's lovely. I'm not trying to say Strawn's not nice or you shouldn't go via Strawn. Sometimes going via Strawn is what you want to do because Strawn's a lovely place to go. But if you're just trying to get to Launceston as fast as you can, Strawn's not the way to go. But I don't want to start disrespecting Strawn. Strawn's great. I'll take this off so you can hear me better. So, non-monic factorization. Who can remember from yesterday? What am I going to finish off that with? Ax squared plus bx plus c, ... Anyone? That's monic. That's from yesterday. Good. A equals 1 is monic. Yep. Or it could be less than 1. It could be a fraction. Yep. So A does not equal 1. But thank you. We got there, didn't we? Yep. A does not equal 1. Does it look like a not equal sign? Not really. Hopefully that's okay. So A not equal to 1. E.g. 2x squared plus 3x plus 1, or negative x squared plus 4x plus 7. Although having said that, if it was just negative x squared like that, I'd probably still treat it like a monic just by taking a negative 1 outside the bracket. Do you know what I mean? So I'd be left with negative 1 outside of x squared minus 4x minus 7, and then I'd treat this thing inside the bracket as a monic. Yeah? Okay. Or a half x squared minus 2x plus 3/4. I don't know, whatever. Pi x squared would also work. So basically, if it's not equal to 1, then you've got a non-monic factorization. And there are, when you get things like a half x squared, there are other techniques that will probably help you make more sense of this. But nevertheless, here we go. I've got some examples I'm going to show you how to factorize with, but I'm going to pause the video in a sec because I'm going to just challenge the class with a problem, and I'm going to use my method called the diamonds method to solve the problem. Let's see if you can beat me in the class, because you've said that you've done non-monics in class already, and is your way the most efficient way? Question mark. So I'm going to pause the video and I'm going to move to the whiteboard to do this. So the diamond method. It's going to feel a bit tricky. So bear with me, and you might even have to go back to this video and have a look at it a few times to make sense of it. But it is worth persevering using the diamond method. Okay, I'll keep it zoomed out now so you can see it. First thing we do is we multiply A by C. And we write the number up in the top right-hand corner. So that would be 2 times negative 1, which is negative 2. Negative 2. Underneath it, I might just put a little red star in front so you can see where it came from. It's A times C. Underneath it, we write B. So there's B. What's the value of B here? Yep. And to be more precise, it's positive 1. So that's where that's come from. That's B. Then we circle the sign from the top line and the number from the bottom line. So we've got 2, so we've got minus and 1 circled. They're our key, oh sorry, and the number as well, I forgot about that. Sorry, do that again. Like that. So what this tells us is I'm looking for 2 numbers that multiply to give me 2, and see how it's a minus here, that are 1 apart. 2 numbers that will multiply together to give me 2 that are 1 apart. So an example of 2 numbers that are 1 apart are 4 and 3. But of course, 4 times 3 is not 2. Okay? But they are 1 apart. If this was a plus, it would mean the 2 numbers have to add up to that number. Okay? So 1 apart. So the 2 numbers that will multiply together to give me 2 that are 1 apart are 1 and 2. Yeah? Okay. So what we do is we write it as a fraction. So a bit of space underneath. I put my 2 numbers as the denominators of my fractions. Over 2 and over 1. Yeah? This is a process. There's nothing to know except can you follow the steps. This sign here goes on the number that is biggest. So we've got a plus here. So we put the plus here. I know it's unusual to put a sign on the denominator, but we're going to do it. And then we ask ourselves, well, we have to get to positive 1. So how do I get to positive 1 from 2 and 1? I subtract 1. So this becomes a minus here. Plus 2 minus 1 is 1. Yeah? All right. The next thing we do is we put, I have to find a different color now. We put the a term, the ax squared term, on top, but without the square. So we end up with 2x on top and 2x on top here. We're nearly there, guys. I'm going to zoom up now because I think it's important that you see what I'm doing here. So that's what I'm left with, 2x over plus 2 and 2x over minus 1. Can you see how we can cancel down that left-hand fraction there? There's a 2 on top and a 2 on the bottom. So if I do that, I'm left with x on the bottom, on the top, and 1 on the bottom by cancelling down. So what does that leave me with? It leaves me with the factors are x plus 1, x from the top, plus 1 from the bottom. That's one of my factors. Next to 2x minus 1 for my other factor. And that is the factorisation. Note for the video, I'm showing the class stuff I did on the whiteboard. You can see by the box method I did on the whiteboard off video, they're the 2 factors. Now, I don't like Mathemagic too often, and this feels mathemagical. It's just like follow the process and it works. Ta-da! But in the case of what we have to do with trinomial factorisation, I think it's worth it. It's worth practicing because I think what you end up with is a really efficient process. No guessing, no checking, no trial and error, just straight up follow the process. You will get the right factors at the end of it, even though it's a bit mathemagical. I'm assuming no one's ever seen this before. Anyone seen it? No, I'd be surprised if you had. Okay, what do you think? Questions? I'm going to do another example. It's going to be the 12x squared minus 14x minus 10 example. So I will show you through the example again. But before I do that, please feel free to ask any question at all, like, wait, how did you get what now? Those kinds of questions are fine. Or anything else that you think might make it more clear to you. This positive one here. So if you have a look at the term here, the middle term, the coefficient, which is implied here, it's not written down, but it's plus 1x, right? So it's the value of b. Yeah, good question, thank you. Any other questions? And often when you ask a question, you're probably asking on behalf of people who are a bit too scared to put their hand up as well. So you're rarely alone, mate. Yeah, so can you see that the value of A is 2 and the value of C is -1? So the first step is to multiply 2 by -1, and that becomes your top number here. Yep, thank you. Anything else? Cool. Don't be frightened to ask questions. Here's the second example then. 12x squared minus 14x minus 10. Okay, so first thing I'll do, actually I'll keep it zoomed out so you can see it all. The first thing I'll do is I'll do that hook of it. There's the highest common factor of 2. So I've got 2 outside of 6x squared minus 7x minus 5. And I'll remember this time, minus 5. So that's our starting problem really inside the brackets. I need to factorize 6x squared minus 7x minus 5. And I'm going to use the diamond method so that you can see it in action. I'll try and be a little bit more natural about how we go about it. So the first thing is my top number. What's my top number going to be? Just yell it out if you think you know. Yeah, I sort of heard a few minus 30s there. Well done. So it's 6 times 5. 6 times minus 5 is minus 30. And I do, now normally, by the way, I just don't have a lot of room in this. Normally I'd be doing it in this space here, just to the corner of the problem. But because it's so tiny, I'm sort of putting it up here. But normally put it in this space. I might do it on the whiteboard. Oh, you can see it on the whiteboard over there on the right. Sorry for the video watchers. Can you see how I've done it sort of just off to the side of the problem? Not all the way over here like I've got over here. Okay, so minus 30 is the top one. Oh, now I have to rub that out, otherwise you'll just copy off the board. So yeah, minus 30 is the top number. And what I tend to do in my problem is I tend to just go, usually in the same color, I'm just changing it so you can sort of see it. I tend to just put an arrow towards it and then go minus 30 off to the side just to remind me what I'm doing. Okay, what's the number underneath minus 30? Yell it out. Yeah. Good job. So minus 7, and then I'm going to circle the top number and its sign and the bottom number without its sign. It's a minus, so I'm looking for 2 numbers that are 7 apart that will multiply together to give me 30. 10 and 3? 10 3s are 30. I mean, ultimately, you don't have to sort of be that sort of intuitive about it. You can just start listing 2 things that multiply together to give me 30, right? 6 5s are 30, but they're not 7 apart. What else? 60 times a half is definitely not 7 apart. 10 times 3 is 30. Oh yeah, they're 7 apart. So you can just sort of go through the different pairs of factors in your head until you find the pair that works. Don't feel like you have to get it in one go. So you've done that. So you're going to go over 10 and over 7. Doesn't matter the order. Over 10 and, oops, not over 7, over 3. The sign goes on the biggest number, so the minus will go on the 10. And I need to get to -7, so I'm going to have to add 3 to that. So it's going to be -10 and plus 3. Yeah? What do we got? We need 6x squared there, so we're going to put 6x on top. So I pop a 6x here, and I pop a 6x here, and then I'm going to cancel down. Give you a moment to see whether you can get ahead of me. Cancel down those. So you're really just looking at the numbers. Is there a number that goes into 6 that also goes into 10? Is there a number that goes into 6 that also goes into 3? And choose the highest common factor and cancel down by that number. Give you a moment to get ahead. By the way, this should be going, I didn't say it, but this should be going in your summary book, right? These examples? Yeah. I'm assuming if you don't have a pen in your hand, it's because you've already caught up. Okay, so 2 goes into 6 as well as 10. So if 2 goes into 6, that's 3 left over. 2 goes into 10, and that's 5 left over. And then 3 goes into itself once. It goes into 6 twice. Yeah, not going too fast. And so then I would say which equals 2 outside. And now I'm reading it. So it's 3x minus 5, 2x plus 1. Done. So you've done it in one line, or two if you include the highest common factor line above, with a little bit of working out on the side to calculate it. Yeah? So it's a really good method. Again, as I've said to you with other things, the process will feel slow to start with, because what you're doing is you're investing brain power into getting a handle on the method, and your brain, who really wants to work as best as it can, will probably feel like, box method, come on, I've used the box method for monics. I know that there's a bit more work here, but sure, that's going to be easier. Can I assure you that practicing the diamond method until it's like this will always be more efficient than the best reverse box method person? Okay? It will be more efficient in the end. It just requires practice to get there. Don't be afraid of a bit of hard work to get that practice in.